Yes, math we do. Here you are. Today, zero product property we learn. Math you understand. Ready you are. Yes, here we go. Okay, everybody. So, as you can see, I've been playing around with camera filters and, well, they seem kind of weird, but hey, who doesn't like Yoda? But today we're not talking about Yoda. We are talking about the zero product property. That's right. Get excited, everybody. It's the zero product property. It's something that we have always loved. Do you know why? Because at some point you had to go and memorize the times tables, didn't you? Yes. I'm in that process right now, actually. It's my child. It's going well. You know, we're going through it. And what did you always love to do? You love to times things by 1 or times things by 0. Why? Because if you multiplied something by 1, you just got itself, which was pretty cool. And if you multiplied something by 0, you got 0. All right. It's way better than those, like, remember 12 times like 8? You're like, what is that one? So we're going to do something called the zero product property. And here we go. If I said this, if I said x times y is 0, and I asked you, what could you tell me about x or y? What could you tell me? What do you know? Well, you don't really know what they are, but you should have an idea. There's something really cool because if you multiply them together, you get 0. So what could you say? You could say 1, we don't know which one of them being x or y. So one of them, x or y, we're not too sure, is 0. There we go. So that's what we know. Well, that's pretty cool. And that is the zero product property. It says this: if two things multiply together to give you 0, one of them has to be 0. And I know what you're saying right now. You're saying, Math Jedi, which one is it? Well, we don't know, but we can go and figure that out. So we need to test the zero product property by basically making two equations. So we're going to do this by making two separate equations. How does that sound? It sounds pretty good, right? Yeah, it sure does. So we're going to make two separate equations. So I'm going to give you some steps right now. I'm going to give you some steps. Some steps. Am I saying that properly? Here we go. Step 1. And I'll put this it'll all come together. We're going to do something that sounds really complicated. Is we're going to set your equation to 0. And that sounds complicated, but it basically means you have to have something equal 0. Okay, that's what you need to do. Okay, so I'm going to give you just a little example here. So let's just say you had something that said, like, I don't know, x squared equals 7x. Why not? Does that equal 0? It does not. So we're going to go and make it equal 0. So I'm going to subtract 7x here. I'm going to subtract 7x here. I'm allowed to do that by the power of algebra. And then what do I end up getting? I get x squared minus 7x equals 0. Yeah, so far so good, for sure. But now I'm going to need to go and factor this. So now I need to go and factor. So a little reminder of factors is you want to look at things that are common. So if you take a look at these two terms, we have x squared and we have negative 7x. The common thing here is x. So I would factor out an x and then make this x minus 7 equals 0. So far, so good. Yeah, cool. That's step 1. Cool. Setting things to 0. So you want to make your equation say equal 0. Sometimes you might even need to do a little bit of factoring. and then having it do that. Because now we know x times this thing in brackets is going to equal 0. So one of these two things is going to be 0. We just don't know which one it is. Well, that's pretty cool, which is going to come to our next part. So I'm going to use this as an example. So either this thing is going to be 0, or the sum of this inside this brackets is going to be 0. But we don't know which one it is. Let's go on to step 2. So step 2. So step 2 is create two equations that equal 0. Because we know one of them has to be true. But we don't know which one. So I'm going to use my last example. So I'm going to so remember where we were, right? We were at x times, was it x minus 7, I think, equals 0. So the first equation I'm going to make is just, so remember, there's two things here, right? So they're two separate things. So we have this one, right? That's one thing. That could be 0. We don't know. Maybe it is. Maybe it's not. Or this thing could be 0. Those are the two things. So I'm going to go and make my two equations. So the first one is going to be the x is equal to 0. It's either going to be that one, or it's going to be this x minus 7 is 0. It's one of these ones. We don't know what it is, okay? We don't know what it is. And now we go on to kind of like, I guess, step 2b. So I'll say that. So I guess this was like step 2a. Let me squeeze an a there. Step 2b would be to solve both. Well, okay, let's just go and do that. So let's just solve this one. So let's solve this one. Oh my gosh, it's already solved. This is awesome. So x equals 0. That's already done. Yeah. Boom. So x could be 0. It could literally be 0. Yes, it could be. We know that. But the other one, if I had to go and solve x minus 7 is 0, I would just add 7 to both sides, right? Add 7 to both sides. And then, whoop, there we go. And x would be equal to 7. So step 3, it's kind of like write your answer, right? I'm going to squeeze it in here. Why not? Because gotta save paper, right? Step 3. That was funny because I'm on a computer. It doesn't matter if I save paper. Step 3 is kind of write your answers. So x could equal 0, or we saw right over there, or 7. Okay, we don't know. But either of those possibly could work. Okay, and why is that? Well, okay, I'm glad you asked that. Why is that? Let's get a really cool color. Hot pink. Let's say x was 0. Just for fun. Okay, so I'm going to use this. So imagine x was 0, and I just put 0 there. It would say this: 0 times 0 minus 7 equals 0. Is that true? 0 times this would be 0, so 0 would equal 0. Yes, it is true. It also says this, so it could be 7, right? 7 times 7 minus 7 also equals 0. Is that true? Well, 7 times this 0 is also 7. Now, yes, it is also true. They're both true. How cool is that? So what does this all mean? What does this all mean? I'll show you where we're kind of going. Maybe a little preview, a little sneak peek. A little sneak peek. A sneak peek. Does anybody ever love watching movie trailers? A little sneak peek of what's going to go on. Seeing some movie trailers. Well, okay. So what are we doing? So what are these things? We call those things solutions that we just found. All right. So those are solutions, and what it basically is. So I'm going to use that example of 0 and 7 is because it said x, right? So remember, this is your x and this is your y. So it said, remember what we just said? We said x was going to be 0 or x was going to be 7, right? So x was 0 or 7. That just tells you where on the x-axis basically a parabola is going to cross. So like there would be 0, and here would be maybe 7. And basically, you're going to start seeing these really cool parabolas like this, whee, like that. And it's just telling you where does it cross on the x-axis. That's what you're going to actually solving. That's pretty cool. I'm going to teach you some more things about this parabola creation stuff, but this is the first step in it, is being able to go and use the zero product property. Okay, I'm going to do some examples now. This is power through some examples, because most kids learn a little bit better by examples. And it might be a little bit so sketchy right now, a little bit confusing, but we're going to get you there. We're going to get you there. Okay, let's do some examples. And basically, what the instructions are always going to be is to solve. So I'll solve. And I'm going to start off nice and easy. I'm going to do like x minus 2. X minus 2 times, oh, I don't know, x minus 4 is 0. So all we know, we know right now that either this bracket has to equal 0 or this bracket has to equal 0, but we don't know which one it is. So we have to go and use the zero product property and just solve each one. So we get two equations. Remember, we always get two equations. X minus 2, just that thing, equals 0. That's either going to be it, or x minus 4 is going to be 0. Right? So now, okay, so at this point, if you're watching this video, I already know that you can do this, like in your sleep. Right? So if I went and just did that, so I added 2 to both sides, right? Added 2 to both sides. I don't know why I started doing this question in here as well. I would get x would be equal to 2. And if I did it over here, x would be equal to 4. So my solutions are x is equal to 2 or 4. That's it. Okay, you don't know which one it is. But remember, if I was going to graph it, and I'm not right now, that I would have a solution on the x-axis at 2 and at 4. And because I know what this is going to kind of look like, it would look like this. That was a horrendous parabola that I just drew. I'm sorry. And there you go. Okay, so that's what we would know. So that's what you just figured out. 2 or 4. I'm not positive which one it is. Okay, cool. That wasn't too bad, right? You'll start doing like student shortcuts pretty quick on these ones, because you can quickly realize what it is and that sort of thing. So let's just do another one. Let's say you had, I don't know, x minus 9 all squared equals 0. Ooh, that's a good one. That's a good one. So what is this one going to be? Well, this means x minus 9 times x minus 9. So x minus 9 times x minus 9. That's what it means, right? So this is going to be nice and easy, because when you set them to 0, they're both. You only get one equation, right? It's easy. Cool. So what's this going to be? So x is going to be 9. That's it. That's your solution. What? So it just crosses, it just touches the x-axis just at 9. I wonder what that would mean. I don't want to give it away yet. But there you go. We're going to get into that whole solving things later, so we're not going to get into this one too much. Let's go back to one of the original ones. Let's say we had d times d plus 4, right, equals 0. So again, your one equation is d is equal to 0. Your other equation is d plus 4 equals 0. And you have to go and solve both of those ones. This one's already solved. Yay! For this one, you have to go and subtract 4 from both sides. That's all. So d is equal to negative 4. So d is either going to be 0 or it's going to be negative 4. Okay, cool, nice. Now, we need to also understand how to get it into that part. So that's the part that maybe was a little bit like, what just happened here? So sometimes you're going to see this instruction. Factor the polynomial. So factoring, again, is taking things apart that have similar things. So like If I said to like factor 8, you could say like 2 and 4, and things like that. When we're looking at, let's say we're looking at something like this, 3x squared plus 9x. So I said I wanted to factor this. So what do we need to do? So to factor, you look at the coefficients first. So first you look at 3 and you look at 9. And you say, what's the factors of 3 and 9? You say, well, the biggest factor is 3. And then you look at x squared and x, and the biggest factor would be x. Yeah? That's the greatest common factor. We call that the GCF. That's your GCF. So then what's left over for this one? Well, what's left over is 3x times what is 3x squared? X. And 3x times what is 9x? 3. And that's what you would end up getting. Now, great thing is you can always go back and check. If I went and multiplied this again, so 3x times x, did I get 3x squared? Yes. And 3x times 3, did I get 9x? Yes. So look, okay, so yay, I did it right. Cool. Now, why do you need to do this sometimes? Because sometimes you need to go and set things to 0, and you need to factor first. So let's go and try this other one. So let's just try this one. So here's another little example. Is let's say you had to go and do 10 x to the 4th plus 40 x cubed. Why not? So look at your coefficients, 10 and 40. What's your GCF of that one? So 10. X to the 4th and x to the 3rd. How many of these x's are common? Well, 3 of them are common. So we say x to the 3rd. So that's your GCF. And now what's kind of left over? Well, 10x cubed times what is 10x to the 4th is just another x. And 10x cubed times what is 40x is just 4. And there you go. Now let's go and put it all together. Let's put it all together now. You guys are doing great, by the way. So here we go. It's going to call factor and solve. So let's say we had, where should we go? Sure, why not? 16a to the 4th plus 12a. Oh, this is a good one. So take a look at that, 16 and 12. What is your GCF of 16 and 12? What's that one going to be? GCF, I think it's going to be 4. 4 like that, yep. And a to the 4th and a, there's only one common a. Great. So now, what do we end up getting? 4a times what is 16a to the 4th? Well, that's going to be 4a to the 3rd. And 4a times what is 12a? It's going to be 3. Oh, I forgot to put down this was equal to 0. I'm sorry, I forgot about that. There we go. So now this all equals 0. Great. So now let's go and set my equations to 0. So 4a is going to be 0, or 4a cubed plus 3 is going to be 0. Why did I make this so ugly? I just did. Okay, that's okay. So for this one, how do I make this basically solve this one? Solve this for a, right? So we divide by 4, so this a is going to be 0. Okay, that's a good one. Yeah, easy. This one's got a little more work. I don't know. This is why I should always do my examples beforehand. Let's go and subtract 3 from both sides. Let's go and divide both sides by 4. And now let's take the cube root. Let's go and take the cube root of that. Wow, this became a horrendous question, didn't it? It truly did. What is the cube root? I gotta grab my calculator for that one. You guys have a calculator right there? No, you don't. What? Why not? You should always have a calculator on hand. You never know when you might need it. If I took the cube root of negative 3/4, it would be negative 9.9. Of course it would be. Okay, so A is equal to negative 0.9-ish. So there we go. So my solutions were 0 or negative 0.9. Okay. That wasn't a pretty one. Let's try another one.
Okay, all you math Jedi out there, hopefully you learned about the zero product property. Thank you for coming to Dagobah. I hope you can get your X-Wing up and out 'em and go and rescue all of your friends. Until next time, have a good day.